Hello, everyone. Welcome to our exciting journey into the world of social studies. Today, we're going to explore the fascinating concepts of scale and distance. Our presentation is called Exploring the World, and it's designed especially for fifth graders like you. Over the next few slides, we'll learn how to understand maps, distances, and how the world is connected. So let's get started and have fun discovering new things. Today, we're going to explore what you'll learn in this session. We'll start with understanding the different types of map scales used in mapping, which is essential for interpreting distances accurately. Then, we'll look at how to use a map scale to measure actual distances between places. We'll also clarify the meaning of the phrase, "as the crow flies," which refers to the straight line distance between 2 points. We'll review some important vocabulary words, such as ratio, which is a comparison between the map distance and the real-world distance. For example, if the ratio is 1 to 100,000, it means 1 unit on the map equals 100,000 units in real life. Next is statement, which is a sentence that describes the map scale, like saying 1 inch equals 1 mile. We'll also cover route, which is simply the path you take from one place to another, and shortcut, meaning the shortest way to get between two locations. And of course, we'll revisit "as the crow flies," emphasizing that it's the straight line distance, not the actual travel route. To make this interactive, I'll ask you, which vocabulary word have you heard before? Think about it. This will help you connect these concepts to what you already know. Have you ever wondered if the distance between two towns is the same whether you travel by airplane or by road? Well, a map scale helps us figure that out. It shows the relationship between the distances we see on the map and the actual distances in the real world. The key point here is that the scale line, which looks like a visual ruler, is just one way to represent a map scale. There are actually 3 main types of map scales. First, there's the scale line, which is a visual ruler that you can measure directly. Then, there's the scale ratio, like 1 to 100, which uses numbers to show the relationship. And finally, there's the statement scale, which is a written sentence explaining the scale. And here's a fun question for you. Can you find the scale on this map? As we go through, keep in mind that understanding map scales is crucial for interpreting distances accurately, and it ties right into our overall theme of reading and understanding maps effectively. So, what is a scale line? Well, it's basically a visual ruler that you find on a map. It shows you the real-world distance that a certain length on the map represents. For example, if you see a line that measures 2 centimeters on your ruler, that might equal 100 kilometers in actual distance. The ratio helps us understand this better. In this case, it might be something like 1 to 100 centimeters, which means 1 centimeter on the map equals 50 kilometers in real life. Now, how do you use it? It's simple. First, measure the scale line with your ruler. Then, note what real-world distance it stands for. After that, you can use that same scale to measure other distances on the map. Just apply the ratio you've learned. And here's a fun part. I have an interactive activity for you. Take your ruler and measure this scale line right here on the slide. Try it out. This will help you get comfortable using the scale line to estimate distances on any map you might encounter. All right, now it's time for us to practice what we've learned with a fun challenge called the Scale Line Challenge. On the slide, you see an example of a scale line, which helps us understand how distances on a map relate to real-world distances. The key point here is that, in this example, 2 centimeters on the map represent 100 kilometers in real life. This ratio is what we call the scale. When you're working with maps, understanding this scale is crucial because it allows you to convert measurements on the map to actual distances. Now, let's look at the first question. It asks, if 2 centimeters on the map equal 100 kilometers in real life, then how many kilometers does 1 centimeter on the map represent? Think about it. Since 2 centimeters equals 100 kilometers, then 1 centimeter must be half of that, which is 50 kilometers. So the correct answer here is B, 50 km. Moving on to the second question, it asks about half of a centimeter, which is 0.5 centimeters. If 2 centimeters are 100 kilometers, then 1 centimeter is 50 kilometers, as we just discussed. So for half a centimeter, or 0.5 centimeters, we would take half of 50 kilometers, which is 25 kilometers. That means the correct answer is B, 25 km. This exercise really highlights how understanding and working with scale helps us interpret maps accurately and efficiently. Remember, the key takeaway is that the scale relates a specific length on the map to a real-world distance, and being comfortable with these conversions is essential for geographic understanding. Now let's talk about the scale ratio, which is a way to show the relationship between the distance on a map and the actual ground distance. It uses numbers separated by a colon, like 1, 100. The first number represents the map measurement, and the second shows the real-world measurement. For example, if you see 100, it means 1 centimeter on the map equals 100 centimeters on the ground. So, the actual distance is 100 times larger than what you see on the map. Here's another example, 125,000. That means 1 centimeter on the map equals 25,000 centimeters in real life. We can also express that as 250 meters or 0.25 kilometers. It's important to note that the ratio is always written with the map distance first, followed by the actual ground distance. Now an interactive question for you. What does the ratio 1:50,000 mean? Think about it. This means 1 centimeter on the map equals 50,000 centimeters on the ground. All right, let's go through some practice questions to really solidify our understanding of ratios. First up, question 1. If 1 centimeter on a map represents 100 centimeters of actual distance, how much would 5 centimeters on the map represent? The options are 100 centimeters, 250 centimeters, 500 centimeters, or 1,000 centimeters. The correct answer is 500 centimeters. This means that if 1 centimeter on the map equals 100 centimeters in real life, then 5 centimeters on the map would be 5 times that, which is 500 centimeters. Moving on to question 2. What does the ratio 125,000 centimeters mean? This ratio tells us that 1 centimeter on the map corresponds to 25,000 centimeters, or 250 meters, on the ground. So, the actual distance is 25,000 times larger than what we see on the map. It's a way to understand the scale of the map compared to real life. Finally, question 3. Which ratio shows a larger area? The options are 100, and 125,000. The answer is 125,000. Here's why. The larger the second number in the ratio, the larger the area being represented. So 125,000 means each centimeter on the map stands for 25,000 centimeters in real life, covering a much bigger area than 100, which only represents 100 centimeters. Overall, these questions help us see how ratios communicate the relationship between map distances and real-world measurements, especially when we're dealing with large areas or distances. So let's talk about the type 3, statement scale. This type of scale provides the map's scale in a sentence form, which can be really helpful for understanding distances easily. For example, you might see a statement like 1 centimeter equals 1 kilometer, or 1 inch represents 10 miles, or even 2 cm equals 50 km. These sentences tell you directly how measurements on the map relate to real-world distances. Now, why would you use statement scales? Well, they are very easy to understand because they don't require any calculations. You just read the statement and know exactly what it means. They're clear and simple, making them especially great for beginners or anyone just starting to learn how to read maps. So, how do you use a statement scale? It's straightforward. Simply read the statement and apply it when you're measuring distances on the map. For example, if the statement says 1 centimeter equals 10 miles, and you measure a road that's 3 centimeters long, you can easily figure out that it's about 30 miles in the real world. And here's a fun interactive activity you can try. Create your own statement scale. Think about your own map. Say, in my map, 1 centimeter equals kilometers. It's a great way to practice and personalize your understanding of scales. Remember, statement scales are all about making it simple and accessible. They're especially useful for quick, clear understanding without complicated calculations. All right, let's talk about as the crow flies. This phrase refers to the direct, straight-line distance between 2 points, much like a bird flying directly from one place to another. It's a simple way to think about the shortest distance between two locations. Now, how do we measure this? First, you find the two locations on your map. Let's say town A and town B then. You take your ruler and measure the scale line, which might say something like 2 centimeters equals 10 kilometers. Next, you place your ruler on the straight line connecting the two towns, starting at 0 centimeters at the first town. Then, you look at where the second town lines up on your ruler. That measurement, in centimeters, is your raw data. To find out the real distance, you just convert using the scale. For example, if the measurement between the towns is 4 centimeters, and your scale tells you 2 centimeters equals 10 kilometers, you can calculate that the actual distance is 20 kilometers. The calculation is straightforward. 4 cm divided by 2 cm times 10 km equals 20 km. It's a quick way to determine the straight line distance across the map. And now, here's a little interactive part. Measure the distance between these two cities on your map. This helps you practice and really understand how to find the direct distance, which is often different from the actual travel distance. Now let's talk about road distance, or as I like to call it, the twisted route. In real life, we rarely travel in straight lines. Roads tend to twist and turn, which means that the actual distance we travel is often longer than the straight line, or as the crow flies, distance. This is an important point because it affects how we measure and understand travel routes. So, how do we measure this road distance? First, we need to identify all the road segments between 2 points. Think of it as breaking down a journey into smaller parts. Next, we measure each segment separately using a ruler. It's a simple step but crucial for accuracy. Then, we add up all those measurements in centimeters to get a total. But since we're dealing with real-world distances, we need to convert that total from centimeters into kilometers. We do this using the scale provided. Like in our example, if 2 centimeters equals 10 kilometers, then we can figure out the total distance accordingly. For example, we might have 4 segments measuring 1.5 centimeters, 2 centimeters, 1 centimeter, and 1.5 centimeters. When we add those up, we get 6 centimeters, which equals 30 kilometers if our scale is 2 centimeters equals 10 kilometers. Finally, I want to encourage you to participate. Count the segments and calculate the total distance yourself. It's a practical way to see how these measurements work in real life and connect what we've learned to actual map reading skills. Let's take a closer look at the comparison between straight and road distances. On this slide, we have a table that summarizes the key differences. First, the method labeled, as the crow flies, refers to measuring the straight line distance between 2 points, which is the shortest path possible. This is useful when you need to estimate air distance or get a quick idea of how far apart two locations are. Typically, this distance is shorter because it doesn't account for the actual paths or roads people take. On the other hand, road distance follows the actual roads and routes you would take when traveling by car or bus. This measurement is longer because roads often have to go around natural obstacles like mountains, rivers, or man-made structures such as buildings. So, it's more accurate for planning actual travel, but results in a longer distance. Let's look at our practice problem. The straight distance between town A and town B is 20 kilometers. However, if you were to drive along the roads, the distance increases to 28 kilometers. That means the road distance is 8 kilometers longer than the straight line distance. Why is that? Well, roads can't always go straight. They need to navigate around obstacles and follow terrain features. Now I want to ask you, which route would you prefer, taking the straight line or following the roads? And why? Think about whether you're prioritizing speed, scenery, or perhaps safety. This comparison helps us understand why distances can vary so much depending on how we measure and plan our routes. All right, now it's time to test what we've learned. Let's go through some questions to see how well you understand map skills. First up, what does that scale line on a map help you do? Is it A, to find the map's title, B, to calculate the distance between places, C, to identify landmarks, or D, to draw the map? The correct answer is B. It's all about helping you measure distances accurately. Next, we have the ratio scale, like 1:100. What does that mean? Think of it this way. A, 1 centimeter on the map equals 100 centimeters on the ground. Or B, 1 centimeter equals 1,000 centimeters, C, 10 centimeters, or D, 1,000 kilometers. The right answer here is A. It's a way to understand how map measurements translate to real-world distances. And then there's the phrase, as the crow flies. What does that mean? Is it A, the shortest route by road, B, the straight line distance between 2 points, C, a winding road, or D, the distance covered by an airplane? The correct choice is B. It's about the straight line distance, which is often different from the route you'd travel by road or path. Now go ahead and check your answers. Remember, understanding these concepts helps you read maps more effectively and navigate confidently. Your score out of 3 will show how much you've mastered today's key points.